Alright, so lesson 125. This lesson's all about space heating and cooling, things like that. The biggest focus for us and kind of the biggest task is any kind of electric heating or air conditioning. So this chapter, like several of the others, goes really into detail on some things your everyday electrician is not going to necessarily need to know. So I encourage you, read that stuff, try to wrap your head around it, but don't get hung up on all the details. What I've done here, I just pulled out what I feel are some of the most important sort of broad topics and the stuff that I think every good electrician really should try to grasp. So try to focus on this kind of stuff and fill in the details with all the others that you'll find in there. So again, I'll focus on some heating and air conditioning items here. So really this is just going to be kind of some code requirements and terminology we're going to throw out. So 422.11 tells us the overcurrent protection must be sized to the value indicated on the nameplate. The electrician need do nothing more than size the conductors and overcurrent protection according to the nameplate. So essentially what they're telling us here, the manufacturer is kind of on the hook to tell us what size wiring, fuses, circuit breakers we need to provide for this stuff. And we'll talk about where and how you find that information. But the nice part about this, there's not really a lot of calculation that we need to do as the electrician. It's done for us by the manufacturer. 422.12 tells us central heating equipment other than fixed electric space heating must be supplied by an individual branch circuit. So basically, if it's a central heating item in a house, whether it's a gas furnace that still has an electric connection to it, some kind of a heat pump, whatever it is, it must be on an individual branch circuit if it's your central heating for the house, for the residence. And the thought is you don't want that circuit having some kind of nuisance trip. Say it's a gas furnace, you could hook that to a 15 or 20 amp circuit, so you could run your lights off that too. Issue is if there's some kind of fault, you trip that, they don't want to risk having your central heat off due to some other nuisance tripping. So it must be an individual branch circuit for central heating. Okay, so 422.62b1 nameplate shall specify the minimum size supply circuit conductors ampacity and the maximum branch circuit overcurrent protection. And that's kind of like that previous code reference I just read. Again, we'll talk about how you actually size that stuff here. And the first of those terms I want to hit is what you're going to see as minimum circuit ampacity, or MCA as it's abbreviated. So if you're going to look on a piece of heating equipment, they should have on that nameplate MCA, stands for minimum circuit ampacity. And really what that tells you is your circuit must be sized to this minimum. In other words, your wires must be able to handle that size, whatever the amperage is in the MCA. So that's kind of how you size your wiring. So they do mention, and your book goes into BCSC, I think it's a branch circuit selection, whatever it is. Regardless, the textbook kind of indicates that MCA is an antiquated term, BCSC is the new term. I'm here to tell you I've never seen BCSC outside of this textbook. MCA is still the industry standard for sure. And then the next term here, maximum overcurrent protection, or sometimes maximum overcurrent protection device, or maximum, they'll have MOCP or MOPD, whatever the case, they all mean the same thing, maximum overcurrent protection device. This is how we size, as the name implies, our fuses or our circuit breaker. So notice on the previous slide we had minimum circuit ampacity, so our wire must be at least this big. Now we have maximum overcurrent device, meaning our overcurrent device cannot be any larger than that. That's the largest it's allowed to be. Reason being, minimum circuit ampacity, your wire has to be able to handle the current flowing naturally. Why maximum on your overcurrent device? Reason being, we want to make sure if there is an issue, if that unit is working harder than it should, we need that breaker to trip. We don't want the unit overloading itself. We also don't want the conductors overloading either. But anyway, the point being, it's a fine line there. They both are similar acronyms, MCA, MOP. In MCA, the M stands for minimum. In MOP, it stands for maximum. Tough to keep straight, but try to drill that into your head because it is an important distinction. One last issue I want to touch on there. They get into a section on HACR rated breakers, stands for heating, air conditioning, and refrigeration rated breakers. That's not an issue anymore. In the past, not all breakers were HACR rated, so if you were going to use a breaker to power some heating equipment, or air conditioning or refrigeration in this case, you had to make sure you had supplied an HACR breaker. That's not the case. Nowadays, all listed breakers are HACR rated. I have seen in a handful of prints, there'll be an asterisk on the panel schedule. It says, and the asterisk means must be an HACR breaker. So essentially, in that case, it means unless I'm pulling old breakers out of the shop, it's not really an issue. Anyway, HACR, we don't really have to sweat that anymore. So just to wrap up, we had sort of two really key terms. If you only take two things away, first is that term MCA, or minimum circuit ampacity. That's how we size our wire. Our wire must be at least big enough to handle this ampacity. MOP or MOCP, maximum overcurrent protection device size. Again, that's how we're going to size our breaker or our fuses, right? Those are the two biggest takeaways out of the entire chapter. If you don't take anything, make sure you take those two facts.